Hi students, welcome back to my channel SADHIK Physics. So where we are learning the physics very easily. So in the last video, so we discussed ray optics and optical instruments. No, so because of due to the lengthy, so we discussed only the theoretical part. No, numerical part of this optical instruments was pending. So we'll complete that numerical part regarding the optical instruments. No, so we'll discuss in this class. No, clear? So I think if you did not watch our optical instruments video, first video, so please go through it and come back to this video, no, so that you can understand very clearly, no, right. So all the formulas, no. So one more time, all the formulas we can just recollect it, no, those who did not watch, no, please. Therefore magnifying power can be written as tan beta by tan alpha. So simple microscope, no, therefore so d by u minima for simple microscope, no, u should be there, no, simple microscope. So if a image is at d, 1 plus d by f, this is image is at d, so d by f image is at infinity. Compound microscope, no, we already discussed. So compound microscope magnifying power is nothing but a v naught by u naught into 1 plus d by fe. So this image is at d, so v naught by u naught into d by fe. So this is at infinity. So please don't follow this one, no, right. So that you don't depend upon the formulas, no, because different, I already told you separate if any 2 or 3 lenses are there, therefore separately deal with each and every lenses, no, so as a lens formula. So magnification can be written as m naught into me. This is for compound microscope. Clear? Telescope already, tube length we already discussed, no. Therefore this is v naught plus, so therefore ue, so we can rewrite it, no. This is for d, right. U naught plus fe will be your tube length. For telescope already we discussed tube length, it will be equal to f naught plus fe. So therefore here magnifying power is nothing but f naught by fe, image is at infinity. So therefore tube length it will be equal to f naught plus ue. So therefore magnification power is nothing but f naught by fe into 1 plus fe by d. So this is image is at d. So these are the formulas, no, we already discussed. Very important is this one, no, and these formulas, no, is most important. These all formulas are developed because of due to this one only. This is your ultimate source. Clear? Now come back to this, we will see one by one, no. Still clarity if you want, no, please go through the video so that you can understand each and every step very clearly, right. Now we will go for first question, no, right. If you are not able to see it, right, please just listen to my words, no, so that I will explain the question. Focal length of a convex lens is given. There is a one convex lens is given, focal length is given. How much now? 2.5 centimeter. He is asking find maximum and minimum magnifying power using the simple microscopes. This is a simple microscope. Maximum magnifying power is nothing but a d by u minimum. This is nothing but a 1 plus d by f. So 1 plus d is already you know it, no, 25 centimeter, no, by 2.5 means 1 plus 10, therefore 11 will be your magnifying power, no. So this is your maximum, therefore magnifying power minimum, therefore du, therefore d by f. So therefore 25 by 2.5, 10 will be your magnifying power. That is what I told you. Therefore simple microscope we can have maximum magnification is 10 or 11. Now we will go for one more question, no? Right. Therefore a man with a normal vision means d is equals to 25, you can take it now, reads a book with a small prints using the magnifying glass of focal length 5 centimeter. Focal length is given as how much, no, 5 centimeter. What is the closest distance and farthest distance at which he should hold the lens from the print so that he can read easily? So he is asking u, right. So u is asking, no, therefore so magnifying power will be maximum. So when it will be now d by u minimum. This should be the minimum distance 1 plus d by f. So d is 25 by u minimum distance, no, it is nothing but 1 plus, therefore d already you know it, no, normal vision is 25 by 5. How much now? 5, therefore it is 6. So therefore u minima can be written as 25 by 6 centimeter, no, this is here u minima, you have to calculate. So therefore here u maxima, therefore magnifying power will be minimum, therefore d by u max, therefore d by f. Clear? So therefore it is 25 by u max, it will be equal to 25 by 5, get cancel out, no. So u max distance is nothing but a 5 centimeter. More than that 5 centimeter, no, therefore real image will be formed, no. So therefore here image is at infinity, image is at least distance of distinct vision. Clear? I understood, no? So now we will go for another concept now, right? So another question. An object is seen through the simple microscope. Simple microscope means simple convex lens now. Our focal length is 12 centimeter. Clear? 12 centimeter. Find the angular magnification produced if the image is formed at near point of the eyes, which is at 25 centimeter from it. Okay. An object is seen through the simple microscope. Find the angular magnification. Angular magnification, so is formed at a near point, which is at 25 centimeter. Therefore angular magnification is nothing but 1 plus d by f. That's all. What you can write it now? 1 plus 25 by 12. 12 to 2s are 24. So 2 point something, no. Therefore here, so here it will be the 2 point something, you will get it now. Therefore 2 plus 1, 3 point something, you will get it here, magnification, no. Clear? So just approximation, no, you can write it. Clear? So this is the simplest one, no, simplest question. Okay. Now we'll go for one more. Right, a 10 diopter lens is used as a magnifier, simple microscope, no. Where should an object be placed to obtain maximum angular magnification for a normal eye? So simple thing, no. Therefore here, so maximum magnification is maximum, that is nothing but a d by u minimum, it is nothing but a 1 plus d by f. Clear? So therefore first of all you have to calculate the focal length. So focal length it will be equal to, therefore our power it will be equal to, focal length is nothing but a 100 by power, so 100 by therefore 10 centimeter, no. Therefore it will be the 10 centimeter will be your focal length. Therefore here where should your object be placed, where this u minima should be kept, no. So therefore it will be the 25 by u minima, 1 plus 25 by 10, so 2.5, therefore plus 1, 3.5, 25 by u minima, this you will get it as 3.5, that implies u minima you can get it as 25 by 3.5, that is nothing but a 25 into 10 by 35, 5 5s are 25, 5 7s are 50 by 7, 7 7s are 49 nearly, so therefore 7 point something in centimeters now. Clear? Right? So you can calculate very easily. Understood? No? So if you see the previous videos, no, so that you can understand very clearly all this one. So here one more question, no. A compound microscope has a magnifying power is 30x. The focal length of the eyepiece is 5 centimeter now. Assuming the final image is at least distance of distinct vision, magnification produced by the objective. So therefore here is asking now m, therefore m naught into me. So therefore he gave m is nothing but a 30, Clear? So m naught is asking now. Therefore, me we want to calculate it now. Image is formed at least distance of distinctive vision 1 plus d by fe. 1 plus d is nothing but 25 by 5. So therefore, total is 6 now. So substitute here now. Therefore, mo is nothing but 30 by me, 30 by 6 now. Therefore, 5 will be your magnification created by the objective is 5. Clear? Right? We'll see one question now here. The angular magnification so is given as 30 times is desired using the objective and eyepiece now. So therefore, it is nothing but a compound microscope no. So magnification is given as how much now? 30 times. So final image will be what? Inverted, magnified, all this one no. Therefore minus 30 it will be equal to objective and eyepiece. Clear? So now what will be the distance? What distance will you set between the objective and eyepiece no? If the compound microscope forms final image is at infinity. Final image is at infinity. So is asking what? So is asking L. So image is at infinity, final image is at infinity means what you have to get it now. So here definitely here there will be a intermediate image will be formed. So then it will be the parallel to this. Clear? Then it is a parallel to this. Image is at infinity. Clear? So this distance is nothing but a fe. Clear? So here he is asking then eyepiece no. This is your objective. This is your eyepiece. So here there will be a object. It will be there no. Then clear? So this is nothing but a VO. So L will nothing but a VO plus FE. We want to calculate it now. So first let us calculate FE. Already we know it now. FE is how much no? FE is nothing but a 5 centimeter. Therefore L is nothing but a VO plus 5. So we want to calculate VO. That's all. So but here he gave the magnification no. Therefore with this one now we can come from the reverse no. We will calculate ME. So because MO we want to calculate now, right? So ME, so we can write down 1 plus D by FE. So 1 plus D is how much now? 25 by 5. So therefore is how much now? 5, 6. So magnification of the eyepiece it will be the 6 no. So MO can be written as minus 30 by 6 no. So how much it will be now? Therefore minus 5 MO. Clear? Right? So MO we can rewrite it as, so we know it, we want to calculate this one now. VO we want to calculate it now. Therefore magnification in terms of VO, lens formula I discussed already. Right. So magnification in terms of VO, so can be written as therefore FO minus V naught by FO. So we can write it as like a minus 5. So FO is how much now? 1.25. 1.25 minus VO by 1.25, it will be equal to minus 5. That implies VO, this is taken now, minus taken here now, therefore 6 into 1.25. Clear? So 6 into 1.25, how much now? So 6 5s are 30, 12, 13, 14, 15, 15, 1, 6 1 is 6, 7. So 7.5. Therefore L can be written as 7.5 plus 5. So 12.5 centimeter will be your, so the distance between the objective and eyepiece. Clear? Right? So now we will go for one more question. No? Right. So in compound microscope, object is placed at a distance of 6 centimeter now. So object where it is placed now? At 6 centimeter. UO is given now. Therefore UO is given, that is nothing but 6 centimeter minus. From the objective of the focal length now is given as 5 centimeter focal length of the eyepiece. Find out the magnifying power of the compound microscope. when the least distance. Okay, magnification is asking no, therefore m naught into me. So first image is at least distance of distinct vision. Me is given as 1 plus d by fe, 1 plus 25 by fe is how much? No, fe is nothing but 10. So therefore 3.5 will be the magnification now. So therefore MO, here U is given, no, U magnification due to objective, you can write down F by F plus U, therefore FO and FO. So what is given now? FO is nothing but 5 by 5, this object distance is minus, therefore minus 6, no, so therefore it will be the minus 5. So magnifying power of this one is nothing but minus 5 into therefore 3.5. So what you can write it now? 25, 5, 2, 15, 16, 17, 17.5. So will be the magnifying power now. Clear? So in this way you can calculate the problems related to this one. No? So we'll go for some more. We'll see some more questions. No? Right. So in a compound microscope now, object is placed at a distance of 6 cm from the objective, of focal length is 5 cm, eyepiece is 10 cm. Find out the magnifying power of the compound microscope when final image is formed at infinity. I think we discussed this one. Yeah, distinct vision. Okay. So therefore here find out the magnifying power. So therefore magnifying power is nothing but a magnification due to objective and magnification due to eyepiece. So therefore image is formed at infinity. So therefore images is formed at infinity. Infinity is nothing but a d by fe. Clear? So d is how much now? 25 by fe. Eyepiece is how much now? 10. So therefore 2.5 will be the magnifying power due to eyepiece. And objective, so therefore MO can be written as here 6 cm it is given, no? Therefore F by F plus U. So therefore F is how much now? 5 by 5 minus 6. Clear? So therefore minus 5, right? So magnifying power is nothing but a minus 5 into 2.5. So what you can write it now? So therefore here 25, 10, so 12.5. So magnification will be this compound microscope. Clear? Right. And now we'll go for another question now. Let us see. Now in compound microscope the distance between both the lenses is 19 centimeter. Therefore L is given how much now? 19 centimeter. So the focal length of the objective and eyepiece are given as 2 and 3. Find out the magnifying power of the compound microscope when final image is at infinity. Therefore here magnification is nothing but what? How much now? We want to calculate MO into ME. So final image is at infinity. So what you can write it now? ME is equals to D by FE. Clear? D is how much now? Already you know it now. 25. Objective is this one now. Therefore 2 and eyepiece is 3. So 25 by 3 now. Right? So therefore here final image is at infinity. Therefore L value we can rewrite it as, so V naught plus FE. Clear? V naught plus FE. Why? So because here this is your objective, this is your eyepiece, means so final image is at infinity means this intermediate image is at FE only. So therefore FE is how much now? 3 centimeter. Therefore what you can write it now? V naught plus 3. So V naught is equals to how much now? V naught is equals to, so therefore 19 minus 3. 19 minus 3 means it's nothing but a 16 centimeter. V naught it will be the 16 centimeter. This is nothing but a 16 centimeter. Clear? So now we want to calculate magnification due to the objective. So therefore F minus V by F. So objective F naught. F naught is how much now? 2 minus 16 divided by 2. how much now? Minus 14 by 2, therefore minus 7. So how much it will be now? Magnification objective is how much now? Minus 7 into eyepiece is nothing but 25 by 3. So nearly 3 2s are you will get it, no? Therefore now you can calculate it now. This is 2, therefore nearly 2 means 2 into 25 nearly 50. So above the 50 it will be the your magnification. Clear? More than 50 it will be your magnifying power. Clear? So now let us go for another question. Right, a small telescope is there. There is a one telescope, right? Has an objective of focal length is nothing but 80 centimeter. Eyepiece is nothing but 2 centimeter. So if the final image is formed at infinity, this is very important, no? Therefore final image is at infinity. So what is the magnifying power of the telescope? What is the separation between this one now? Therefore very simple one now. When it is infinity, so L value will be equal to f naught plus fe. So therefore magnification is nothing but f naught by fe. So this you can rewrite it as f naught 80 plus 2, therefore 82 centimeter. This is the separation, no? So f naught is 80 by 2, therefore nothing but 40 will be your magnifying power. Clear? So in this way you can solve the problem, no? Very easily. Now we will go for one more question, no? Right, a magnifying power of an astronomical telescope is 5. Magnification is how much, no? Is nothing but 5. M naught into me, it will be equal to 5. Actually it will be the minus will be your, if the focal length of the eyepiece is about 4 centimeter, find the focal length of the objective lens and also find the distance between the, when final image is formed at infinity. Very simple one, no? So final image is at infinity means is very simple one now. Clear? So therefore here what you will get it now? L is equals to f naught plus fe. So he is asking distance between this one now. So focal length of the eyepiece, so he is given now. Eyepiece is given and focal length of the objective we don't know. We don't know this one now. Therefore f naught plus 4 will be your this one now. What is the magnification here now? Magnification is nothing but f naught by fe. F naught we don't know by 4. So we want magnification is given is 5. So therefore it will be this is nothing but 5. F naught it will be equal to 20 centimeter. So therefore here you can write down 20 plus 4, therefore 24 centimeter will be your magnification. Right. Here a telescope as an objective lens of focal length is focal length of the objective is given as 200 centimeter. It is used to see the 50-meter tall building at a distance of 2 kilometers. What is the height of the image formed by the one? Okay, right. Therefore this is only the objective lens is there, no? So therefore here there is a one tree is there now. This is one tree. So height, tree not, this is a building. So this height of the building is how much now? 50 meters. Height of the building. Clear? So at what distance now? 2000 meters. Clear? So 2 kilometers means 2000 meters. Therefore here now we can see that this is your height of the image we want to calculate it now. So obviously compulsory it will be formed at FO because it is a very far distance after this. So that means this is your alpha and this also alpha. So same angles are there, no? Therefore what you can write it now? Tan alpha is equals to height of the building, height of the object by object distance, no? Therefore object distance, right? Object distance is equals to height of the image by focal length of the objective. Clear? So this triangle and this triangle. Clear? So now he is asking height of the image. No, this is height of the object is nothing but 50 by, therefore 2000 is equals to height of the image by focal length is how much? No, 200 centimeters means, so therefore 2 meters it will be your, so therefore it will be the 1000, 10 get cancelled, 5 ones are 5 20s are, so height of the image is equals to 1 by 20 meters will be your, right. So therefore in centimeters if you want to calculate it, no, then you can multiply it, so with 100, so 100 divided by this, no, 5 centimeter, no, it will be your answer. Clear? Right. So now let us go for one more question. No? So the diameter of the moon is given, no, and the distance from the earth is given, no, therefore it is seen by the telescope, no. So from the objective and eyepiece of 4 meters and 10 centimeter, what will be the angular diameter of the image? Angular diameter for normal adjustment. Normal adjustments means what? See, for normal adjustments means, so image at infinity. Clear? So image is at infinity. Clear? So now what you can write it now? Therefore here, so what will be the magnification produced now? Therefore FO by FE. So what will be your magnification now? FO object is nothing but a 4 meter, that means 400 centimeter by 10 now. Therefore here 40 will be your angular magnification now. Therefore, so here we can write down it will be the beta by alpha. So we want to calculate the beta because angular diameter means what? Beta. Clear? So therefore here beta is equals to 40 into alpha. So first of all, what is making the angle? No, let us see here. No, this is your alpha. So suppose this is our moon. This is the moon. So this is the diameter of the moon. No, diameter of the moon. Therefore here, so this is alpha. This is your diameter of the moon, distance of the moon. Therefore tan alpha. So what you can write it now? Tan alpha is nothing but the diameter of the moon. Diameter of the moon is how much now? 3.5 into 10 the power of 3 divided by distance from this sun now 3.8 into 10 the power of 5 kilometers. Cancel here no. So therefore here 3.5 means nearly 0.9. So taken top no. Therefore what you will get it now? So this 10 the power of minus 2, 0.9. Therefore 0.009, right. So therefore here is a smaller no, therefore alpha value is this one no, this many radians. Clear? So therefore beta 40 times of this one no, 0.009. So 10 get cancelled out now, 4 into 0.09. So therefore 1836, 0.036. Okay. So therefore here 36 means 2 zeros, you should get it down. That means 0.36 radians. I don't know in terms of degrees, no, you can calculate in terms of degrees. Clear? So radians you know it, no, therefore, so 180 degrees is equals to pi radians. You can convert it, no, so from this. Clear? Now we will go for another question, no? Let us see. Now an astronomical telescope has an objective and eyepiece are given now respectively. To view a object 200 centimeters away from the objective, the lens must be separated by. Therefore, here this is one objective. So this is your eyepiece. Therefore, he is asking this length. Clear? So focal length of the object is given. No? Therefore, FO is given as 40 centimeter. So FE is given as 4 centimeter. To view an object of 200 to view an object 200 centimeters away from the objective. Therefore, this is about 200 centimeter from the sun. The lens must be separated by, okay. So, final image, suppose this is 20 centimeter means, so what you can write it now, therefore image will be formed at somewhere here now, this is now clear. So, here the image is created. Now, we will calculate this distance now, this is nothing but a VO, we will calculate it now. So, therefore, VO, how to calculate it now? Apply the lens formula, 1 by F is equals to 1 by V minus 1 by U, this is UO, UO, this one. This is 1 by FO is nothing but a 1 by 40 is equals to 1 by VO minus of minus plus 1 by 200. So, 1 by VO taken here now 1 by 40 minus 1 by 200. So, this is 5 into 5. So, 5 minus 1, therefore 4 by 200. So, VO is equals to 200 divided by 4. So, therefore, how much now? 50 centimeter. This should be the 50 centimeter. Clear? If the final image is at infinity, so therefore definitely, so this is a 50 centimeter, no? So, if the final image is at infinity, this should be nothing but FE or lower than that one, no? Therefore, nearly 54 centimeters should be your answer now. Okay, so 54 will be your answer here, no? This is your answer, 54 centimeter. Clear? Right? See. Now, let us see one more question. No? Okay. These are all slightly lengthier questions. No? Therefore, let us study this one clearly. A compound microscope consists of an objective of focal length is 1 centimeter, no? And eyepiece of focal length is 5 centimeter. Compound microscope separated by distance, this one. No? At what distance from the objective should an object be placed to focus it properly so that the final image is formed at least distance and angular magnification in this case? No? Angular magnification. No? So, that means here, so therefore he is asking, this is your so this is your objective, this is your eyepiece. Therefore, at what distance from the objective? Therefore, here one should get no. Therefore, this is U0 is asking U0. So that final image will be formed at where? So, here this is an intermediate image, no? Final image will be formed at least distance of distinct vision. No? Clear? So, he is asking this distance is given now, how much now? L is equals to 12.2 centimeter, no? So, this distance no can be written as, so this is nothing but a V0. Therefore, UE, V0 plus UE will be your answer now, right? So, tube length is given now. Tube length how much now? So, 12.2 centimeter. So, that it will be nothing but a V0 plus UE. So, first let us calculate UE, right? So, why? Because image is at distance, least distance of distinct vision. So, first let us go for eyepiece, no? Eyepiece. So, therefore, for eyepiece, no? For eyepiece, no? Therefore, focal length of your eyepiece how much, no? Eyepiece is given as 5 centimeter. Clear? So, length, objective focal length, okay, right. So, therefore, so here 1 by FE, so goes to 1 by VE minus 1 by UE. So, 1 by FE is nothing but a 1 by 5. So, 1 by VE is nothing but a, so this side it is only is there. So, 1 by 25 minus, so minus of 1 by UE. Taken here, no, 1 by 5 plus 1 by 25 is equals to minus 1 by UE. So this I will write it as 5 into 5. So therefore UE is equals to 25 by 6 minus. So we can write it as 25 by 6 now. How much it will be? 4.16. This is UE, 4.16. Clear? So therefore VO we want to calculate it now, so that from this one now. So this is 12.2 is equals to, so how much it will be now? VO plus 4.16. VO value will get it now, taken separated now. So 8.04. So VO I got it no. If I got it VO 8.04, I can calculate UO. How to calculate it now? Therefore here again, so 1 by FO is equals to 1 by VO minus 1 by UO. 1 by FO is how much now? 1 by FO is how much now? 1 by 1 centimeter. It will be equal to 1 by VO. So 1 by VO is given now. VO is positive there now. So positive because this side no. Therefore 1 by 8 I will take it now easily. So 1 by UO. Therefore here I will take it as 1 by UO is equals to 1 by 8 minus 1. So therefore, so this I will take it as a 7 by 8. So UO is equals to 8 by 7 centimeter. That is actually minus, will get it now. So therefore what will be the this object distance, you have to keep it now. Therefore minus 8 by 7 you need to keep the object now, so that you can able to get the images at these two distance of distribution. So what is the angular magnification now? So you can calculate it now very easily. Angular magnification, M is equals to M naught into ME. So M naught, so therefore V naught by, therefore here it is V naught by, therefore U naught into 1 plus D by FE. So V naught is how much now? Therefore 8 by, therefore 8 by 7 into 1 plus 25 by FE. FE is how much now? 5. So 5 is a, therefore here 8 it cancel now, minus 7 into 6 now. So 8 into minus 42 will be your magnification. Clear? Right? So that's what I told you when you are solving the problems now. So best method is solving separately. So then you can able to get the answer very easily. Clear? Right? So now we'll go for another question now. An astronomical telescope is to be designed to have a magnifying power of 50 in the normal adjustment. No, if the length of this one is given, no, find the powers of objective in this one. Okay, this is simple thing. No, again normal adjustment means image is at infinity. Clear? So that you can remember now. Therefore, image is at infinity. L is equals to F naught plus Fe. Clear? So magnifying power is nothing but F naught by Fe. So magnifying power is 50. So tube length is how much now? Tube length is nothing but so 102 centimeter. Clear? So therefore F naught is equals to 50 into Fe. So substitute in this one now. Therefore we can calculate the F naught and Fe value. Substitute in this one now, F naught value. So therefore 51 Fe is equals to 102. So Fe is equals to 102 divided by 51. So 51 times 1 is 2 is, therefore Fe is equals to 2 centimeter now will be your. So f naught is how much now? 50 into 2, therefore it will be 100 centimeter now. Clear? So powers of this one, no? Power of objective is nothing but 100 by f naught. 100 by f naught is nothing but 100, 1 diopter. Objective power, no? Therefore eyepiece power is how much now? 100 by fe, 100 by therefore 2, so therefore 50 diopter. Clear? Right? So in this way you can solve the problems, no, very easily. Now we'll go for next one, no. Right, the eyepiece of an astronomical telescope has a focal length of this one, no. Telescope is focused for normal vision of a distant objects, no, when tube length is 1 meter. Find the focal length of the objective and magnifying powers of the telescope. So again for normal adjustment means what? Image at infinity. Clear? So therefore eyepiece of astronomical telescope, therefore fe is given as how much now? 10 centimeter. So tube length is given as how much now? 1 meter, means 100 centimeter. So therefore f naught plus fe, so is equals to 100. So f naught is equals to 100 minus 10, therefore 90 centimeter now. Clear? So these are the focal lengths, no. Therefore here magnifying power f naught by fe, f naught is how much now? 90 divided by 10, therefore 9 will be your magnifying power of this telescope now. A simple questions. Clear? Next one. Yeah, therefore so some of the few questions, no, which I already selected here, no, therefore still if any time is there, no, therefore we will select some more difficulty level questions, no, then we will come with one more video. So therefore, so till now therefore our optical instruments numericals, no, so is completed now, right. So thank you for watching. Please subscribe to my channel. Those who want to learn physics, no, please for them you can share my videos, no, so that they can learn very easily. Thank you for watching. Please subscribe.